Good evening, all. Today we're going to be doing the Geneva part that is called the week two for our class now. It's week two, Geneva mechanism drive. And the drive portion of this system is the print 002. I'll bring that over. So this is the drive print. We're going to be building the Solidworks assembly in this video. And the first thing I want to comment on is the file structure. Again, I've talked about how important that is, so I really want to make sure that everybody starts off with a good file structure. What I have here, I have a week two created for the drive, and these are the files that I downloaded off of the Blackboard. So I have an STL file, which actually should not be there. So I accidentally uploaded an STL. I've since fixed it in the Blackboard. So what you should have is a drive.solidpart, SODPRT. That's the part that you want. If you had downloaded previously and you have an STL file there, go ahead and delete the STL and then bring this one in. So I have the part in this folder, and now what I'm going to do is I'm going to go and grab a fresh Kurt Weiss assembly. So back here I have fixturing files, which is something I made for myself. I have a Kurt Weiss folder. And then I'm going to grab all three of these files and bring them in fresh. So I have an assembly, the moving jaw, and the main body. I'm going to copy all three of those, and I'm going to paste those brand new into week two. And something that I didn't do last week that I will do this week is I'm going to rename the assembly so that it matches the print number or the name of the part that we're working on. So instead of simple Kurt Weiss, I'm going to go ahead and rename this to op10 because this is my first operation for this part. And then I'll do the part name. So P01-01-002 drive. Okay. I don't want to rename the main body or the jaw, just the assembly. If you rename these, you'll have to re-import it into the assembly and rebuild it, which isn't a big deal. But if we do it this way, we shouldn't have to rebuild anything. So now that we have these files all in one folder and we have a renamed solid assembly, I'm going to go ahead and open it in SolidWorks. And if you do it this way, you can just click and drag it. Or the other way you could do it is you could do File Open and just open the assembly. So I'm going to minimize that. And here we have our fresh Kurt Weiss. And again, the moving jaw should be free, left to right, and then everything else should be stationary here. So now that we have this set up, now we can look at the print and start talking about our part setup like we did last week. So we have a couple more features here. It's a little bit more complicated. The first thing I will look at is the outside dimensions. So we have 1.5 inches from center to the end here. We can multiply that by 2 to get our 3 inches here. And then we have a 3-inch dimension here from top to bottom. So overall, the actual rectangular portion of this part is 3 by 3. And looking at the dimensions here, we have a 2-place decimal. So in reality, we probably could buy like a 3-inch by 3-inch square plate. Normally it would be saw cut, so you would have to machine one end of it anyways to get it square. So what I mean by that is you could buy a 3-inch piece of cold rolled steel or something like that. That would probably be intolerant. You could leave this edge as bought, right? But then if you cut it off of a bar in this direction, there's no guarantee that your saw is square or parallel to this surface, so it might be cut, at an angle this way, or it could actually be cut depth-wise at an angle. So you'd have to at least face this section here and this here. So what we could do is make a piece of stock that is 3 inches wide, and then go like 3 1/4 or 3 1/2 long, and then machine the 2 edges here. In order to do that, you'd probably have to hang it outside of the vise on one side and then on the opposite side. So that makes the Mastercam setup kind of silly. Normally what you would do is probably do that in the tool room first, especially if you're making one of these. Maybe you have someone already square the block up for you without doing the extra setups just to get these edges square. What I'd like to do just to make it simpler for us is I'm going to go ahead and say that we're going to use a stock block that is 3¼ by 3¼ and what we'll do is we'll go extra on the thickness. So we'll use the work holding, the extra thickness for work holding, and then we'll just machine the outside profile using 2D high speed. So we'll go 3¼ square, and then what we'll end up doing here is we will go ahead and make the thickness 1/2 inch or so, something like that. That way we have a 1/4 inch of stock to hold in the vise while we're doing our work holding. So let's go ahead and draw that piece of stock. That should be the first thing that we do. So I'm going to go ahead and make a new part. I'm going to go to File, New, select Part, and click OK. And we're going to draw that stock block. So I'm going to go to the Sketch button. I'm going to make a new sketch. I'm going to click on the top plane. And I'm going to start by making the square that we're going to use for 3¼ by 3¼ So I'll go ahead and left click, make that square. I'll go Smart Dimension, and I'll dimension up our square. So we want to do 3¼ by 3¼ We're going to click OK on that, exit the sketch, go to the Features tab, select Extruded Boss Base, and again, we're going to go ahead and make this a 1/2 inch thick. If we were making a lot of these, this is kind of a waste of stock, right? So if we were going to make 1,000 of these, we may have a different strategy. But for what we're doing, we're only making one piece. We'll talk about the other strategies later on when we start looking at the assembly again. But for now, this will work out great for us. So we have our 3¼ by 3¼ by 1/2. I'm going to do File. Oh, actually, let's change the color while we're in here. So I'm going to go to the left-hand side and go to Part. I'm going to right-click and go to the colored ball that says Appearance when you tooltip over it. I'm going to select the part. And then I'm going to change my color to green or blue, something like that. But again, you can change this to whatever you'd like that's not red, or the selection color, which is usually purple. So now I'm going to go ahead and file save this. I want to save it inside of that folder that has all the other stuff in it, right? So so wherever the Kurt Weiss is living and wherever your main drive solid part is. And for this file name, I'm going to name it op10 P01-01-002 drive stock. I think this is probably a good convention right here. That'll work out well. And then we'll click save. Now we can leave this part open because we're going to insert it into the SolidWorks assembly. I'm also now going to open the part file, which is the 01-002 drive part, solid part, SLD PRT. Again, make sure it's not an STL. Go ahead and click on that. And we're just going to confirm this is the right part. Everything looks good here. You can change the color on this if you want to. I'm not going to worry about it. For now, I just want it open so that it's easier for me to start doing the assembly work on it. So I'm going to go ahead and open up or go find the SolidWorks assembly that I already started with the vise. And usually that means you can minimize the other two windows. And here's the Kurt vise that we were working on. So because we have the two pieces already open, when we go to insert components, you're going to see that the open documents here are nicely laid out for you on the left-hand side. That's why I like having them open first. I'm going to start by bringing in one piece of the drive. And then I'm going to go back to insert components, and I'll bring one more piece in here. That's the drive stock. We're also going to talk parallels after this, but for right now, I'm going to go backwards a little bit and set this stuff up first and then talk about what size parallels we need to have for this. So we're going to go ahead and mate the part file into the stock, and we're going to keep in mind that we want it centered in there, so we have to do a little bit of math to figure this out. I also want to make sure that we face the top, so that's what I'm going to actually establish first. I'm going to leave 60 thousandths on the top for facing, which means I'm going to mate this surface and this surface, and then offset it by 60. So let's start with that first. I'm going to go to mate. I'm going to select the top of the part, the top of the stock. It defaults to coincident, and then I'm going to go to distance, and I'm going to go ahead and set that to 0.06. Now we're going to have to look at it from the side in order to make sure we're going in the right direction. One way you can do that in this is you can press spacebar, and that gives you a vision cube. And I'm actually going to click on the side view here so I can see where we are. And it looks like we're correct. And actually 60 thousandths might be too much for this distance, so it might be just do 0.03, so 30 thousandths. That gives us more material on the bottom to work hold with. So I like that. That's good. I'm going to click OK. And now I'm going to go ahead and rotate over and establish my side end pieces here. So we know that this is 3 inches, and we know this is 3¼ So if I want to have this equal on both sides, we're going to go ahead and mate these so that they're going to be 1/8 of an inch offset. So I'm going to start with this edge here and this edge of a stock here. I'm going to go to the distance again and 0.125 there. And again, I will do the vision cube. Let's see, we'll do that. Oops, I missed it. We can do it now though. Let's go to the vision cube and make sure we're in the right spot. So that looks good, right? That looks about equal. We can double check that by using the measurement command later. Now I'm going to use this side here and do the same thing. We're going to have 1/8 inch offset. So I'm going to go ahead and mate this surface to that surface. And then I'm going to go ahead and do 125. If that's correct, the part should have disappeared. You'll notice that it didn't. So that means we need to flip that dimension. So if we uncheck the flip, it's going to go that direction on the inside. So now I'll click OK. I'll get out of the mate, and I'm actually going to make my stock transparent for a second. I do that by selecting it and right-clicking, and then clicking on the Change Transparency button in the first row, about right in the middle. And now I just want to kind of visually check my part, and I'll use the vision cube to kind of walk around and make sure everything looks even. So I am actually pretty happy with that. Not bad at all. So now we can go ahead and start talking about what we're going to do for parallels. Now, we need to at least have 1/4 of an inch plus, 30 thousandths above the top of the vice jaw, so that when we're doing our machining, we're not going to hit the vise itself, right? So this has to be lifted up a little bit. We can probably just do the math on that. And again, we can double check our dimensions here. We already have 1.5 inch parallels made. I believe that's probably what we're going to want to have. That means we're going to have 100 thousandths of material sticking in the vise, which isn't terrible. You wouldn't want to really rip material off of this like that, but 100,000, terrible. Actually, it'd be more than that, right? Because if we have a 1.5 inch parallel, and then we have this sunk in onto it, that means we'd have about 1/4 of an inch in there, which is roughly what we want. I actually think we may need to go to 1 5/8 parallel in this case to get to look correct, or to get to work out properly. In order to deal with that, why don't we make the parallel first, and then we'll come back. So I think we're going to need 1 5/8. It's really easy to create a new one because all we're going to do is take the 1.5 inch that we made before and modify that. So I'm going to go back into my file folder structure. I'm going to go back into my fixturing folder that has all my fixturing files in it. You'll see that I isolated my Kurt vise and my parallels. I'm going to go into my parallel folder, and I'm just going to open the 1.5 inch ones for a second. And it's going to be real easy to change this. All we need to do is modify that one dimension. Before I modify the dimension, I want to do a save as and rename it as 1.625. That way we're not overriding the 1.5 inches. So I'll do File, Save As. I'm going to go ahead and change this to 1.625. I'm going to save it in that same fixturing file, but I'm not going to leave it there because I want to put this now into the other folder. I want to make a copy of it and put it into my project folder, I call it. So inside of my fixturing folder, I have the 1 5/8. I'm going to copy that, and then I'm going to put it in my project folder for week 2. Again, I want to keep all of my fixturing files and everything I'm using in that assembly isolated in this folder. I do not want to accidentally make it communal and then screw up other files of my own later. So now that I had the parallel in here, I'll go back into the assembly. I'll go to Insert. I do not have that open right now because I closed it to make sure I'm not pointing at the wrong file. So I'm going to hit Browse. I'm going to exit this because this is my fixturing file. I don't want that one. I want to go into my project file and I want to grab the 1 5/8 parallel here. Oh, but you know what? I didn't even modify it. So we need to modify it first. I'm sorry. Hit cancel. Get out of that. We got to go back and actually modify the height on that. So I'm going to open it out of my project file here. And then we'll modify it here. We'll have to modify it in the other folder too. I kind of screwed that up a little bit. My apologies. Real easy to modify this. So under the one boss extrude that we did, I'm going to go to Sketch and I'm going to edit the sketch. And I'm going to change this thickness from 1.5 to 1.625. And then you can click OK. And the solid updates automatically after you exit the sketch here. So I'm going to save that. And I'm going to go to the other folder, my fixturing folder, and I'm going to go ahead and fix that one real quick before I forget about it. Because right now it's labeled 1 5/8, but it's actually incorrect. So we'll do the same thing here, 1.625. Exit and save. And I'm going to close this one again because I don't want to accidentally bring in the wrong one. So now that I'm back in the assembly here and I know what those dimensions are correct, I'm going to insert again, go to Browse, and grab the 1 5/8 out of my project file. Again, not out of my fixturing file, the project file. We're going to go ahead and need 2 of these. So I dropped one. I'll go and browse and get the second one. And now we have all the files that we need, or all the solids that we need in order to begin the full assembly of this. So we did this last week. I'm going to mate the parallels first. I'm going to mate the fixed jaw one the first way, just because it's the easiest one to do to start with anyways. And I want to make sure it's attached properly. So I'm going to bring this surface to the edge of the vise there. That's good. I'm going to bring one of these flat surfaces over to the fixed jaw. And then I want to, or the movable jaw, I want to make sure it's on the right side. That's good. And then I want to attach the bottom of the parallel to the bottom of the solid part of the vise there. So with those 3 things constrained, it all should be attached. And now when the movable jaw gets dragged around, the parallel comes with it. So that's exactly what we want. And then you can see it. So this is the height of the work holding that we have on this. And it looks very slight. So I don't know, maybe we'll modify this. We'll go check this. So that's only 1/8 of an inch in the vise. We'll take a look at it. Maybe we'll modify it. We'll see what happens. That is not a lot of work holding material there. So basically what happens is you're risking the part coming out of the vise. We'll lay this out and maybe we'll actually cover replacing parts. So if we decide that we don't like this height, we can replace it with the 1.5 inches and let it ride that way, and we'll see what it looks like. In the meantime, I'm going to go ahead and assemble the other parallel the same way. So no particular order. I'm just going to go ahead and do the side face. That's on the correct side. Then I'll do the edge, and then I will do the bottom of the parallel down to the bottom of the vise here. Good. And then same deal, I can grab the parallel here and make sure that it's not moving anywhere. And we are in good shape. So the last thing we're going to do here is basically position this in the vise, and we're going to do it centered like we did last time. So I'm going to start by bringing the side of the stock to this vise profile, and then think about what we need to do to get it centered in the vise. So I'm going to go ahead and do this. Now, the vise is 6 inches, 6 inches wide, right? And our stock block is 3 1/4. So we can actually do the math in here similar to the same way we do SolidWorks. So if I do 0, or similar to Mastercam, so if I do 0, right, it's line on line. So then we want to do is 3 1/4, so 3.25 divided by 2, which is 1.625, and that doesn't look right. So actually, what do we want? 1.5? I don't think that's correct either. 3 1/4, right? 3 1/4 stock. See, that takes me a minute sometimes too. 1.25 plus 3 1/4 is 4.5, and then 1.25 plus 4.5 is that. I thought this was 6 inches wide. It is 6 inches, I believe. I'm gonna do some measurements here. Evaluate, measure. So from here to here, 6 inches. Now let's just check the side face of the stock to there. So that's 1 1/4. That's what we just did. And then there to there is 1.5. Okay, no, so I am off by a little bit. So it should be 1 5/8. I think it just didn't look centered to me for some reason. When you want to edit a mate that you exited out of, you can open this caret here next to the mates icon where the staples or the paper clips are. And then we can find the last one that we did. So that's the 1 1/4, and this should be 1.375 is what it should be. And then that is going to be centered in the vise. Now I'm going to go ahead and attach it to the bottom of the parallel. So I'm going to go back into mate. I'm going to grab the bottom. You'll notice that if this is transparent, it's easier to grab the part in the middle that isn't. The only way you can really get a surface that's on a transparent object is if you kind of pick it away from the other object here. So I'm going to click on the bottom of that transparent, and then I'm going to go ahead and click on the top of any of the parallels. That'll get me where I want to be. And then what we want to do is attach this edge here to the fixed part of the vise. And then we'll go ahead and lock this all in together by clicking the movable jaw and bringing that over to the last side. So now with all those mates constrained, we are going to have all our degrees of freedom basically eliminated here. And again, the only concern is with me is that it's possible we probably, you see this space here? This is the clearance that we have to machine around it. So in reality, we could probably drop this down another 1/8 of an inch and have more work holding. And that will enable us to basically sink this down a little bit more and have a more aggressive work holding strategy. An 1/8 of an inch in a vise is not a lot. for this, especially when you're face milling, when you have a lot of surface area, when you have a large tool on the part, you risk throwing the part out of the vise. So um, I don't think I want to go back and fix all that. We could. One way we could do it is we could actually just open this parallel up, and that might be actually a good exercise. So we decided, maybe we want to go a little bit lower, right? Maybe instead of 1 5/8, maybe we want to do not quite 1.5. Maybe we have one that's like 1.563. So why don't we go and edit this part, and then you can see how it updates and relates to the assembly. In order to do this quickly, it's real easy to go to the part from here. So if we select one of these parallels, we can left click on it and then go to open part. And let's just go to the Boss Extrude sketch. I'm going to edit it. And instead of 1.63, let's do 1.56 for height. So 1.563 would be the official size. We'll exit the sketch. And now really simply, I can click on that button over there to kind of put it on the left-hand side. When I come over here on the right, it's going to ask to update and rebuild the assembly. If we click on yes, you're going to see that it actually lowered the sizes down. It updated the file, and you can see now that we've added an additional almost 1/8 of an inch of work holding here. And we can also confirm that we are still well above the vice jaws. So by changing that to 1.563, I think that's a much better strategy there. And obviously the file name is wrong now, but I'm not too concerned about that right now. We could always rename it. Um, well, we wouldn't want to rename it because we break the links, so we'd have to make a new set of parallels and then reinsert them in here. But for now, if you're able to change those and modify the parallels you have in this file to 1.563, I'm perfectly happy with that. So you probably just saw me save it. I'm going to go ahead and just put it in isometric, take a look at it. I'm happy with everything. I'm going to go ahead and save it again. And now we are ready to bring this part into the Mastercam assembly. So go ahead and continue on with this project in the next video, and we will perform the machining operations.